A model using reinforcement learning learns the optimal behavior based on the states and rewards of the environment. However, as the degrees of freedom increases, the complexity of the system leads to an exponential increase in training time and difficulty. Here, we can see that the model using reinforcement learning in 3 degrees of freedom can only translate in the x, y, and z axes. It has learned the optimal policy, which is to bounce the ball on the paddle and ensure that it does not drop. The end goal, however, is to reach human like performance, which encompasses the nuances of rotational movement as well. Adding rotation with 5 degrees of freedom leads to a training space that is too large for the model to learn the optimal policy in a limited period of time. We present human-aided training where the rotational ability of the agent is trained using imitation learning and a human trainer. The human tries to balance the ball on the paddle, and the student agent learns to do the same by imitating the readings of the teacher. Here, we have incorporated 2 neural networks or brains that are differently trained. The first with 3 degrees of freedom using reinforcement learning, and the second with 2 degrees of freedom using imitation learning, both working simultaneously to create a hybrid model which mimics human-like performance. This proof of concept provides concrete evidence that the proposed approach for training agents works well to reach human-like performance and aid them in learning complex, nuanced actions. The next step is to fine-tune the model and experiment if a human expert could train the agent to reach a skill level close to the expert themselves. For instance, a ping pong champion can train an agent to play the sport, and this trained agent can then be used to train a novice individual.